Okay, 5a, we're going to use transformations with the natural log, and it says that we want to start with our base graph of natural log x. So that base graph is this one, so it's y equals ln x. Now what I know about that is for the ln x graph, first of all I know that it has a vertical asymptote at 0. And what I also know about it is it has to cross the x-axis at 1. Now the graph itself is going to look something similar to this. If you wanted to get a decimal for one of the other points here, like we wanted to put in natural log of 2 for instance, just to see how high it is, to have another point that would be there, you can do that as well. And so if you did do that, it would be a little bit at 2 if you wanted to. We have about 0.8 or so, somewhere around there. So if you want to get another point just for axis so you know how high it goes, you can do that also. So if I put in a natural log of 2, then I get something right around there. I get something a little bit less than 1. So that's the base graph that we're going to start with. Now next, we're going to do y equals ln, and I'm just going to do x plus 4. Now what the plus 4 does is it's going to move the graph 4 places to the left. So everything gets shifted over to the left. Now the vertical asymptote that's here, that also gets shifted over 4 places to the left. So what that means is I'm going to have a dotted line that's going to go there. It was at 0 and that got shifted 4 places over to the left. Now this point right here, that's going to move also 4 places to the left. So that's going to end up right here. It was at positive 1, we go 4 that way, it ends up here. And then our other point, if we want to shift the other reference point we have, that's going to be somewhere about right here, which means that the graph is going to do something like that. So that would be what the ln x plus 4 graph looks like. The very last one is where we're going to apply the negative. So now if we have a negative on the outside, we said that's a flip this direction. It flips over the horizontal axis, which means that we're still going to have a vertical asymptote at negative 4, and this is like a pivot point. That point does not change, so it's still going to go through negative 3. It's just that the graph now flips. So instead of this point being up here, it's now going to be down below. So it's going to be somewhere about right here, and the graph is now going to fall. It's going to do something like that. Now you don't have to be that accurate about where it crosses the y-axis unless it specifically tells you to find the y-intercept. Otherwise, it's going to go through somewhere about right there, and the answer key will show the exact graph what it looks like, but I'm mainly looking for sketches. If you have it going in the right direction, this would be y equals negative natural log x plus 4. Now, besides the graphs, it also asks you for some other information as well. It asks you for the x-intercept. It also asks you for the domain, and it also asks you for the VA, the vertical asymptote. Okay, so we have to indicate those off the graph. So x-intercept, and they want you to do this with your final graph. So our final graph, we see that it crosses the x-axis at negative 3. So I'll put that in there. Now domain, I'm going to get that off the graph as well. Now domain is talking about the x values that the graph is using. Starts from negative 4 and it goes everywhere to the right. So that's going to be negative 4. We have to put a parenthesis on that because since there's a vertical asymptote, the graph will never actually reach that point. So negative 4, and it's going to go to positive infinity since everything is going to the right. For the VA, the vertical asymptote, that's the equation, this dotted line right here, and that's going to be x is equal to negative 4. So that will answer the other questions that they want.